So, what is 7-3 talking about? It's talking about proving that triangles are similar. So, there are three ways to prove that triangles are similar. A pair of triangles can be shown to be similar by using the following criteria. Two pairs of corresponding angles are congruent. All corresponding sides are proportional. Proportional is a key word here. Or two pairs of corresponding sides are proportional and the included angles are congruent. So when they're talking about that, this is what they're referring to. So in this situation over here, you have angle-angle similarity. Right here, this symbol in the middle, this means similar. So these two things are similar based off of having two angles that are similar. Um, if all three sides are proportional, in other words, if I compare AB to DE, again, because those are the first pieces of our triangle, and that ratio is the same as comparing BC to EF over here. Again, the second two pieces of our thing written. And then finally, I can compare AC to DF, the first and last, right? The first and last. And if all three sides have the same proportion, then yes, this thing will be similar. And then finally, there's side equal side similarity. So if um, if this side over here, AB, can be compared to DE, the first side's right here, right? And this side here, and then BC right here, and EF right here. That is the second pieces right there. If those two things are proportional, and on top of those two things being proportional, the angle that they create, those two sides, if those are congruent, then I can say that the figures we're looking at are similar. So those are the basic three things, um, three ways to show that triangles are similar. This should look a little familiar, side angle side, because we used the side angle side to show things would be congruent as well. But we weren't looking at proportions of sides. We were looking at the actual length of sides. Same thing over here. Side, side, side may look familiar because we did use side, side, side congruency theorem to prove things are congruent. But again, that's proving that the sides are all the same, not that the proportions are the same. So this is different now. We're looking at proportions. Um, all right, so let's go back here and jump in and look at this example problem. So in this example problem, they're asking us whether or not ABE and DBC are similar. Well, because this top side is parallel to this bottom side right here, that tells me that these crossings, AD and CE right here, those things must be transversal lines. So because those are transversals, angle A over here becomes congruent to angle D over here, and that is um, alternate interior angles. Taught that a couple units ago. And angle C over here is congruent to angle E over here, and that is again because they're alternate interior angles. They're on alternate sides of their transversal line, and they are inside of the parallel lines. So that being said, yes, they are similar, and that's the symbol right there for similarity. Okay, just to make sure we're clear. All right. Another little added bonus piece of information. This crossing right here, at this crossing, this angle up here and this angle down here become congruent to each other based off of being vertical. So I could also say that these um, two triangles are congruent based off of angle, angle, angle. They have all three angles the same, but you don't need to do that right now. Yeah. All right, let's do a few example problems. So number 10 and 11, we're asked to explain whether each triangle um, similarity is true. So are these indeed similar? These triangles FJ, FGJ, FGJ, that small one right there, or medium size one I should say, and GHJ. sorry, J8, JGH, JGH. All right. So when you tackle a problem like this, it's helpful, it's beneficial to break up the figures. So that's what I've done over here real quick. I've broken up this figure. And I've also rotated it a little bit so that they match up with G on the top and yeah, just so they match up with G on the top and their order, right? So from F to G is on the top side right here. From J to G is this same sort of direction right there, right? So they're corresponding now. So I just did that so that it's easier to understand a little bit. All right. So what can we do? What can we do? Well, we know we have an angle that they share over here and an angle that it shares over here. So there's one thing we have. I wonder if this is proportional right here, if FG is proportional to GJ and GJ is proportional to GH, then I can use side angle side similarity. So let's work that math out just a little bit real quick. Okay? All right, so let's put some numbers in there then and look at that. So is 9 to 6 the same as 6 is to 4? Is that proportional? Well, I can reduce both sides. 3 goes in to 9 over here. 3 goes into that 9 3 times. And 3 goes into this 6 over here 2 times. And on this side of the equation, I have a 6 and a 4. Well, 2 goes into 6 3 times. And 2 goes into 4 2 times. All right, so there you have it. That's a big piece of information. Now I know that I have two sides that are proportional, and their included angle, the angle that those two sides make, this angle G right here, that was given to me at 90 degrees and 90 degrees. Well, I should say that this wasn't given to me to be 90 degrees at angle FGJ, but I knew it was 90 degrees because it was 90 because the angle next to it was 90 degrees and they make a straight line. It is fair to say that this checks out and it is a similar triangle. Number 11 wants to know if KLN is similar, right? Is similar to NLM. So is the small triangle over here, KLN, similar to the one it's attached to over here, NLM? It's nice to note that they both have LN inside of them. And again, I'm going to break this thing up so I can look at it and compare some things. In this situation, I don't have any angles given to me, so I'm going to have to check the proportionality amongst all of the sides. I've rotated the figure, I've broken up the figures, and I've aligned them so that they correspond pretty easily. So my K to L is equivalent and corresponding to my N to L. Again, how do I know that? Because in my figure, I have KL, first two letters, and NL, first two letters. Okay? All right, so let me go here and make some equations. Let's see here. I have K to L is 2, and N to L is 4. And that reduces to 1 over 2. All right. L to N is 4, and L to M is 8. And that reduces to, again, 1 over 2. So far, so good. Two things check out. And let's check the bottom two, the last two sides. So K to N is 3 units. All three of my sides have proportionality. So because all three of those sides have proportionality, it is fair to say that indeed, yes, this one checks out as well. Those are similar triangles based off of side, side, side similarity. This next problem says, explain what additional information is needed to use the angle-angle similarity theorem, I guess we should say, the angle-angle similarity theorem, to show that these two triangles are indeed similar. Yeah, I keep emphasizing here, I want you to understand or see this symbol and know that it means similarity. I'm so sorry, excuse me. T corresponds to X. Let me fix that real quick. All right, so T corresponds to X, and V over here will correspond to Y. All right. Let me do a little bit of math real quick. 37 plus 65 plus angle U, I'm going to say angle U, that's going to equal to 180 degrees. I can add 37 and 65 together. 30 and 60 is 90. 7 and 5 is 12. So that's 102 together. So 102 plus angle U is going to equal to 180. And then after I subtract 102 on both sides, angle U is equal to 78 degrees. So if I can find one more angle in here, if I can find one more angle over here in this triangle XYZ that matches up, then we should be similar. But just make sure we understand which ones, right? For this to be similar, my T was 37, so my first letter X, this would have to be 37. If we found out it was, if we're given that additional information that it was, then we'd be fine. Or if we were given over here, that Y matched up and was congruent to V, and was 65 degrees, then it would also be congruent. So that's what we need to know for to answer number 12 correctly. We need to know whether or not one of these other angles is congruent to one of these angles over here. Because we know that Z is congruent to U. We did the math down here to prove it. All right, wonderful. I look forward to seeing how this goes in class. Thank you for watching the video.